Hello, and welcome to my webinar on textual data processing with large language models in the humanities. My name is Gabor Toth. I'm a computational historian at the University of Luxembourg Center for Contemporary and Digital History. This webinar is not meant to be a comprehensive course on artificial intelligence and the humanities. My goal today is much more modest. I would like to give you a taste of the power of large language models. I would also like to give some practical tips on how to harness this power to discover texts. I hope that by the end of this webinar, you will have a better understanding of how AI is revolutionizing the exploration of textual worlds. After this introduction, let's start the first session of our webinar. Today, everybody understands how X-ray revolutionized medicine. Doctors can now see the inner world of our body without surgery. With the advent of large language models, a similar revolution is now unfolding in the humanities and other fields. Seamlessly, with the help of large language models, or LLMs, we can now map the inner world of large textual collections. For instance, we can extract a great variety of information. We can identify the people who are mentioned. We can also visualize the connections between them. Today, large language models facilitate the highly efficient processing of textual datasets. To be fair, processing large amounts of text was already possible before the arrival of large language models, but it was complicated and time-consuming. As a first step, let's have a look at the structure of this webinar. We will have 3 sessions, each looking into different aspects of LLM-assisted textual processing. Today, we will talk about information extraction. At our next session, we will cover data transformations with LLMs. For instance, we will discuss text summarization. After this, we will move to a more advanced field, and we will learn about the use of vector space models, or embeddings, to study the texts. Of course, LLMs have a lot of other capabilities. However, this webinar is limited to these 3 areas. Now, let's focus on information extraction. What is the goal of information extraction? In short, information extraction aims to identify automatically people, events, locations, concepts mentioned in a text or in a collection of many texts. The strength of LLMs is that you can target any sort of information that you think is present in your text. For instance, you can extract physical characters of persons and nicknames of animals. Practically, there is no limit. This lack of limit is an important achievement. Even earlier, we had tools to accomplish information extraction. Nonetheless, these tools mainly target named entities. These are proper nouns, such as persons, locations, organizations, and so on. The tool we earlier used to identify and extract them from text is called the named entity recognizer. LLM significantly surpasses the capabilities of a standard named entity recognizer because its use is not restricted to the extraction of proper nouns. Now, let's see how to write a good prompt to extract information from text. A good prompt has 3 main components which follow each other. The very first component is the declaration of the input data. This is as simple as saying, you will get an English text. The second component is the definition of the task. Again, in case of information extraction, this is straightforward. Your task is to extract people mentioned in the input text. The third component is the declaration of the desired output. We will shortly speak about this. There is a temptation to treat LLMs like humans. I have seen people using polite questions as instruction. Can you please find me people who are mentioned in this text? This is not recommended. It can distract the LLM, and you might bump into issues with hallucination. Finally, it is also recommended to use LLMs to sharpen your prompt. On the slide, you can see two prompts. The one above is my own original prompt I gave to LLM and instructed it to improve this prompt. The prompt below is the result. So next, let's see another question. How can you target and extract more complex information with the help of LLMs? For instance, you want to identify and extract artifacts from text. To accomplish this task, you have different options. The first option, which you can see on the slide, is providing an LLM with examples. That is to say, in addition to the instruction, you can give one or two sample inputs and outputs to the LLM. However, there is also another option. This is the use of a reference resource, such as, for instance, WordNet. On the slide, you can see a prompt relying on WordNet to identify artifacts. WordNet is a lexical database developed at Princeton University in the 1990s. In short, WordNet groups words into different sets of synonyms, abbreviated as synsets. For instance, artifact is a synset in WordNet. It includes words such as device, tool, weapon, and so on. Generally, the artifact synset of WordNet includes man-made objects. When you write your prompt to extract artifacts from a text, you can target this domain with reference to WordNet. Notice that the prompt is a chain of consecutive actions. Also notice how the prompt realizes the process of iteration and then selection based on WordNet. After this, let's see what the good input is for the data extraction with LLMs. Theoretically, you can feed a text of any length to LLMs, but the reality is quite different. The shorter the input text, the more accurate the output will be. I personally prefer to work with only sentences. Before submitting a large amount of text to LLMs, I usually perform sentence chunking and split the text into lists of sentences. Finally, I submit the sentences to LLMs one by one. Of course, I work with batch processing, and I do not use the chat interface when I perform information extraction on scale. In some cases, paragraph-level chunking is more beneficial. It all depends on the purpose of information extraction. After discussing the ideal input format, let's have a look at the ideal output. There is a general problem with LLMs. They are very talkative. They try to give you as much information as they can. For instance, sometimes they offer comments, explanations, examples, and so on. If you want to produce machine-readable results, this is not ideal. Results and explanation will be mixed together. For this reason, it is very important to control the output and make sure that it is structured and machine-readable. Perhaps the best solution is to instruct LLMs to output the results in JSON. It is also advisable to turn off explanations and comments. JSON is a machine-readable lightweight data interchange format. It is readable by both humans and computers. In this webinar, I cannot give a detailed explanation of what JSON is. However, there are plenty of online tutorials about JSON. On the slide, you can see the previous prompt with instructions to create a structured output in JSON. Notice that the prompt explicitly states what the expected output is. It also instructs LLM not to attach comments and explanations. At this point, you have data extracted from a text. But how do you verify that your LLM performed correctly and did not make any mistakes? This is particularly difficult if you work on scale and you have performed data extraction from a large amount of text with batch processing. There are different strategies to evaluate how LLMs perform data extraction tasks. First, you can create a benchmark dataset and evaluate the performance of LLMs against this. The second possibility is the use of random sampling. First, you perform data extraction from a corpus consisting of 1 million sentences. Next, you can randomly select 100 sentences as well as the results of data extraction. Finally, you can check how many false positives you have in the results. If the number of false positives is reasonably low, for instance below 5%, then the results can be considered good enough. If there are a lot of false positives, you are in trouble. You might want to revise your prompts or rerun the process for a second time with different temperature or context window. Before concluding today, I would like to talk about relationship extraction. So what is relationship extraction? As we saw before, in a text there are entities, objects, actions, and so on. The goal of relationship extraction is to identify how they are connected to each other in the text. For instance, relationship extraction aims to identify the actions that connect people co-occurring in a text. How to perform the task of relationship extraction in an efficient way? It is possible to perform this task by instructing directly your LLM to extract, for instance, all agents and the relationships between them. This is what you can see on the slide. However, this might not be the most efficient solution. Instead, I suggest the use of chain processing. For instance, first you can extract all locations from your text. Next, in a different prompt, you can instruct your LLM to identify the events that take place in these locations. As input data, you can give the text and the locations already extracted in the previous step. With this two-step process, the results will be of better quality. Furthermore, it is less likely that you will encounter the issue of hallucination. In summary, today we have seen how you can harness the power of LLMs to target and extract different types of information from text. We have seen a few examples of prompts you can use for data extraction. At the next episode of this webinar, you will learn about applying LLM to transform textual data in machine-readable structures. I'm looking forward to meeting you again. Thank you for your attention.